Hey guys, my name is Rishi and today I'm going to be explaining to you how the Aditalam base structure with linked to variations can form its own binary tree structure. But first, remember in the last video I told you I would make this a program. But first, I need to explain to you the setup because it is quite complex. So I'm going to explain to you the setup first, so that way when I explain the program, most of you won't feel left behind. Okay, so to start off, let's do a quick review. Okay, as you can see here, the base speed when you have 1 is 8 beats. Remember, and each of those beats has 32. Each beat has 4 matre, and 8 times 4 is 32. And 32 matre is the full cycle. Let me show you how that would look. 1, 2, 3, 4, 5, 6, 7, 8. That's the full cycle of Aditalam. If you were to do half the speed, the number of beats would increase because you're taking longer to complete a word. In this case, that's how the number of beats would increase. 16 beats would be that same cycle I just showed you, but repeated twice. If it was 32, then you would do that 4 times. But however, if you did 4 beats, that's half a cycle because you're increasing the speed. That basically means the word finishes twice as fast, 4 times as fast. You get the idea. 4 beats here would be 1, 2, 3, 4, and 2 would just be 1, 2. So hopefully that gave you a quick Aditalam quick overview. Like I've explained Aditalam in depth in previous videos, so if you haven't caught up, just look at those and you'll be fine for this. But now let's get into the scenario. Let's get into scenarios. What are main scenarios? Well, consider a scenario as a list. For those of you that don't know what a list is, that's okay. I'll explain that in the programming part of this. But essentially, think of the scenario of holding multiple different parts to that scenario. Okay, and then that's essentially what a list does. A list holds different parts, different elements, and that's what we're doing here. So let's go through. I made 4 base examples. Let me explain those to you. So first, you have the original speed, which is 1. Matre here is 8. The word stays the same throughout, and the binary values you can see they're the same. The reason for that is very simple. You take the number of matre here. This is the original matre. Be careful. Original matre, 8 divided by 1 is 8. Now why is there 100? Well, that's simple. The binary value of 8 is 100. Same thing here. 4 divided by 1/2. Dividing by 1/2 is the same thing as multiplying by 2. So 4 times 2 would be 8. Same output. And you can see here from scenario 3 it would be the same. 16 divided by 2 would be 100. 32 divided by 4 would be 100. Let me show you how that would look on the bottom. Regular speed would just be 1, 2, 3, 4, 5, 6, 7, 8. Right? But if we were to do half speed, this 4 matre would go from 1, 2, 3, 4 to back to the original speed. 1, 2, 3, 4, 5, 6, 7, 8. Same thing for 16, right? If we were to do 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. That would just go back to the original as 1, 2, 3, 4, 5, 6, 7, 8. And then you get the idea for 32 and 4. Now, let's go to the back, which has different variations, which are deviating from this base structure. So as you can see, we have 4 different scenarios here, and you can see the binary values, the outputs are different. How? Well, the same logic applies. 16 divided by 1 is 16. So essentially, the speed never changes. Showing a speed of 16 matre is half a cycle. So that would be, for the word itself, you can see there's taka, tari, kita, taka. That goes as follows. Taka, tari, kita, taka. It lasts 4 beats. Remember, a beat is 4 matre, so that is 16 matre. And that speed never changes because whether you divide or multiply by 1, it would never change. So that would stay the same regardless of how you did the program in this case. 32 and 2, you can see speed here is 32, the original matre is 32. So this would mean it would go through a full cycle. So it would go from 1, utaka, sorry, I messed up. Ta, tari, kita, taka. It's really slow, you can see that, right? The taka lasts 2 beats, the tari lasts 2 beats, and you can see that it's being stretched out. And that's basically dividing 32 by 2, you get 16, and that binary value of 1000, because 16 as a binary value is 1000. I've explained that earlier, but You get the idea. But 16, you can see this one has 4 zeros. How? 16 divided by 1/2 is 32. This is basically the inverse of number 2. Here, we started off slower when we're going faster. Here, now we're starting off faster when we're going slower. So we go from taka, tari, kita, taka to taka, tari, kita, taka. Because remember, by having the speed, you're making it go making it go slower. This is how the output values connect to this speed and matre when you do the calculations. Now I'm going to show you the last one, and then we can explain how this connects to the tree structure. Okay, so 64, that's the original. That's 2 full cycles. So that would be da ga dari kita da ga. That each slur of the word lasts 4 beats. So it's very, very slow. You usually don't go much slower than that, but for the sake of this video, I'm showing you how that would go. And this goes 4 times faster. By doing that, you go from 2 full avartanams, or which is a cycle, another word for cycle, to half a cycle, which is taka, tari, kita, taka. So what does this all mean for the tree structure? Let's answer the big question here. Essentially, you can think of these individual scenarios as combined together for a whole as the root. You know, you have the tree root, everything begins from there. Essentially, think of it as that way. And these different scenarios are the parts of that big root, or the branches, as you'd expect from a tree. And these new scenarios, which are the branches, have their own individual smaller branches or parts, which are the different categories associated with the scenario. So, because each scenario has a speed, matre, word, and binary value attached to it, those are the individual branches. And the same way would work from the front as well. I hope this gave you a good idea of how a preview of the program, and in the next video I will explain to you the actual program in pseudocode, and please don't forget to follow me on Instagram, follow me on YouTube as well, and I really appreciate you guys' support for those of you who are subscribed and watching my videos. Thanks, peace out, bye.